Okay, this is the intermediate value theorem, which is used in the next example on your handouts. You may want to just try to take a minute to write this down, but I'm going to explain what it's talking about. The intermediate value theorem says that if you have a function f evaluated at a and a function f evaluated at b at two different values, okay, if f at a and f at b have opposite signs, then there is at least one value of c between a and b for which f at c is equal to 0. Okay? It says, therefore, the function f of x equals 0 has at least one real root between a and b. Okay, let me show you what all that means on the graph. They're just saying, let's say we take two values for x. We'll call one of them a, one of them b. If I plug that value into the function, if I evaluate f at a, I'm going to get some y value. Let's say if I plug a in, I'm going to get -2. Okay, so this point would be a, -2, or whatever that a value is. If I plug b in for the function, and I get an opposite sign, let's say I get +3, so I would have a point b, +3. This intermediate value theorem says that when I evaluate two different numbers, when I plug them into the function and I get values that are different sign, that one should be a +3, not negative, but +3. If I get different signs, that just shows that there is some number between a and b that we'll call c that will be a 0 or a root to this function. So on your example, back on the sheet number 13, it says to use the intermediate value theorem to determine whether the polynomial function has a real 0 between the given integers. All that you have to do is plug those two values into this function. So first we're going to find what is f at 1. So I would have -2 times 1 cubed plus 10 times 1 squared minus 3 times 1 minus 8. Okay, if I simplify, this would just be -2 plus 10 minus 3 minus 8. So I would have 8 minus 3 would be 5, minus 8 would be -3. So f at 1 is -3. And then I would plug in the second value that's given. I want to find f at 2. So I'm going to plug in a 2 everywhere I have an x. -2 times 2 cubed plus 10 times 2 squared minus 3 times 2 minus 8. So 2 cubed would be 8 times -2 would be -16. 4 times 10 would be 40. Minus 6 minus 8. So I would get -16 plus 40 would be 24. Minus 6 minus 8. So this would be +10. Okay, so f at 2 is +10. So the intermediate value theorem just says if you plug in two different values, like we plugged in 1 and 2, one gets a negative value, one gets a positive, then this graph is going to cross the x-axis. So there is a 0 between 1 and 2 of your polynomial function. So as far as your answer, it would just be yes, that there is a 0 between those two values of x. Okay, the next thing I want to talk about is the turning points of the polynomial function. So we say that if f is a polynomial function of degree n, the graph of f has at most n minus 1 turning points. So we talked about how the multiplicity affects the behavior of the graph at the 0. This will tell you how many turning points the graph should have. So if I look at number 14, my leading coefficient or my highest exponent is x to the third. This tells me that this graph should have at most 2 possible turning points. Okay, so it's going to have a maximum of 2 turning points, one less than what your highest exponent is.